All right, let's talk about something that is, no joke, the most important foundation you'll ever need for data structures and algorithms. We're going to master Python arrays. So, why are we starting here? Get this. A staggering 90% of all data structure problems, I'm talking stacks, queues, hash maps, you name it, they're all fundamentally built on arrays. Seriously, if you get this one concept down, you're pretty much most of the way there. Now, if you've used a language like C++ or Java, you know the classic definition of an array, right? It's a neat, continuous block of memory where every single element is the exact same type. Now, hang on to that thought because it's super important for understanding the little twist Python throws at us. So, here's what we're going to cover. First, we'll hammer home why arrays are the absolute foundation. Then we'll look at the two main paths for using them in Python. We'll start with the basic array module, then level up to the powerhouse that is NumPy, and finally, we'll see all the cool stuff you can actually do with this knowledge. Okay, let's dive right in with the foundation. Really understanding how Python handles this critical data structure is essential if you're serious about, acing those coding interviews or just building really efficient software. Okay, so here's the first big curveball. Python, out of the box, doesn't really have a true built-in array like C++ or Java. Now, I know what you're thinking, wait, what about lists? And look, that's a totally fair question. Python lists are amazing and super flexible, but they aren't true arrays. They don't guarantee that all your data is stored next to each other in memory, which can be a massive performance hit, especially when you're crunching a lot of numbers. So how do we get around that? Well, that leads us right to the two main ways we can actually work with proper arrays in Python. And picking the right one is all about choosing the right tool for the job. Yeah, this table pretty much sums it up. On one hand, you've got the array module. It comes built in with Python, it's very strict about keeping all data the same type, and it's pretty basic, one dimension only. On the other hand, you have NumPy. This is the industry standard, it's way more flexible, and its killer feature is handling multi-dimensional arrays. All right, let's tackle that first path, Python's built-in array module. Think of this as the basic, no-frills toolkit that comes with Python. It gets the job done when you just need a simple array and you have to be really strict about the data type. The catch with this module is you have to tell it exactly what kind of data you're putting in it, using something called a type code. So you see here, if you want an array of integers, you got to use the code I. For floats, you use F or D. This is how it forces that same type-only rule. And bam! Here's that rule in action. Look at this code. We're trying to create an integer array. You can see the I type code, but we sneak in a float, 9.5. Python just stops dead in its tracks and throws an error. Yeah, no wiggle room. It's super strict. Okay, so if the built-in array module is that rigid, what's the deal? What do people actually use? Well, let's explore that second path, the absolute powerhouse library known as NumPy. This is the professional-grade tool for pretty much all numerical work in Python. And just look at the difference. It's night and day. We run the exact same code with NumPy, and it just works. See, NumPy is smart. It sees that 9.5, that float, and it just upgrades the other numbers 2 floats to make everything work together. No errors, just a perfect array of floats. So what is it? What makes NumPy the absolute go-to choice for pretty much everyone? Well, it really boils down to a few superpowers. First, creating complex arrays is a breeze, often just a single line of code. Second, like we just saw, it handles different data types like a champ. And third, the real game changer, multidimensional arrays. These are absolutely essential for things like machine learning or image processing. But the secret weapon under the hood? Raw speed. NumPy is written mostly in C, so its operations can absolutely run circles around plain old Python code. And when we talk about multidimensional arrays, this is what we mean. It sounds complicated, but it's not. Just think of it as a list of lists or a bunch of 1D arrays stacked on top of each other, all organized into neat rows and columns. This simple structure is how we represent everything from a spreadsheet to a digital image. Okay, so we've got our foundation. We know how to make these super fast, flexible arrays with NumPy. So, what's the payoff? What cool stuff can we actually do now? Okay, first up is one of the most powerful and honestly coolest things you can do with arrays, slicing. It's just a fancy word for grabbing a specific piece or a slice of an array to work with. Let's break this down. When we say my array from index 2 to 5, we're grabbing a subsection. The thing you always have to remember is the start number, 2, is included, but the end number, 5, is not. So we get the elements at index 2, 3, and 4, which are 30, 40, and 50. And this right here is the ultimate party trick for Python programmers. It's so elegant. That little : -1 syntax is just a shorthand that tells Python to start at the end, go to the beginning, and step backwards one element at a time. It's a full reversal in one beautiful line of code. So let's bring it all home. What's the big takeaway here? While it's good to know that Python's built-in array module exists for basically any serious work in data structures, data science, or machine learning, NumPy isn't just an option, it's the standard. The combination of its power, its flexibility, and its raw speed is just unbeatable. So there you have it. You've just laid down the bedrock, the single most important building block in all of data structures. The only question left is, with this solid foundation now in your toolkit, what incredible, complex things are you going to build next?